Good evening, everyone, and welcome to YGC 10 Explore webinar series. So, as part of YGC 10, we have organized a series of webinars in order to identify the problems that are there in different fields, and through that to find opportunities and to work on those during the YGC 10. So as part of this, we have been conducting a series of seminars in different fields such as food tech, edu tech, and so on. So today we have Muhundan Dharmakulasingham here to conduct this, to let us know the opportunities that are there in the field of blockchain. Muhundan is a PhD student at University of Surrey, and he will be now explaining us, or rather letting us know, the different opportunities that are there in blockchain. Muhundan, over to you.
Good evening all. Thank you, Aganaka. It's a pleasure to get involved with YGC with Light Hub after 2 years. Coming to blockchain, the blockchain has started in 2008 with the introduction of Bitcoin, but the blockchain has its footprint in its own major fields, be it like IoT, medicine, supply chain, government, real estate, most of the fields it has a footprint. The main reasons are blockchain's ability to solve the market problems like transparency, trust on data, time consumption, cost, and accountability. So I started in blockchain nearly 3 or 4 years ago with Light Hub through the project, and after that I got chance to involve with some blockchain project, and I'm happy I share my knowledge and with YGC community again. I assume there are different audience with different level of knowledge and exposure with blockchain. So I will go to the principles behind the blockchain, then go to the opportunities and the concerns we need to consider in designing the blockchain applications. So let me share the presentation. Okay, so what is blockchain? So internet is a worldwide network to share information with others. But is it suitable to transfer the values? Let's say if you share the files and money in the internet, will the ownership change in the internet? No. But in the blockchain, we say internet is to solve that problem. So in conventional world, let's say we want to transfer money, we transfer to the banks. If we do online, we transfer to the PayPal. Why? We trust them, we don't trust each other, we don't trust peers, because there might be double spending problem. So you may give to myself, at the same time, the same money you can give to another one. So I don't have any way to track or trust whether you have actually money or not. It's the same for the property registration. So we go to the lawyers or government and we register through them because trust issue. We use the third party to trust and check the ledgers or records and verify it. So, but this approach has some limitations, some problems. The one is it's time consuming, of course, and it's cost. We need to pay for them. So what if we build a network or we build a system where we can trust each other, peer-to-peer network, but we can trust without a third party. So the blockchain is a solution, or blockchain has a functions to solve these problems. So as blockchain is a distributed database that stores tamper-proof ledger and transaction data. The distributed database, because normally if you take database that is centralized, you have a centralized database, it has point of failure. If something happened to database, everything will change. But in the blockchain, it's a distributed database. Every node or everyone participate in the blockchain have the same database. So if you want to add it, you can't add it without informing to others, because they will identify whether if you add it. And also it has some other tamper-proof mechanisms to the cryptography and linking each other, so you cannot edit or remove any data you entered. If entered, it's entered. You cannot edit or remove it. So it has a common ledger, and it's visible and everyone can access it. No one can own it or no one can control it. It's equal priority for everyone. And these mechanisms, these security features are achieved through the cryptographic mechanisms. And of course, when you have equal priority, you will get problem if you have some conflict. So how to solve this? Those are done through the consensus mechanisms, through written in the content solve rules. So these are some properties of blockchain. It's a digital record of transaction. It's decentralized. In the famous big internet applications are distributed, but the control is within one party. That means that is not decentralized, centralized. They can control you, even though it's distributed. But the blockchain is decentralized, so each and everyone has same priority, same access level. No one can control you. And it's immutable or tamper-proof. You cannot edit or remove anything. And you can view history of all the transactions. So you can track back to the original and you can identify where was the wrong. So these interesting properties make the blockchain popular in all major fields. So let's go to some principles in the blockchain. One principle is distributed open ledger. Let's say we want to transfer money from A to B. We have open ledger, anyone can see it. So there we put entries or transaction. So saying that we transfer money, A has this amount of money, then A has transferred to B, then B transfers money to C. So this is open ledger, and this same node copies are available in all the nodes. That's why it's distributed. So even though one tries to change the node, some values in the A, it will B and C can identify it. It's almost impossible. It's very hard to change in all the nodes. Same problem. Other thing is that's why it's secure. You cannot add without being detected by others. Other technique is hash. Hash is the digital footprint of the data. So we calculate the hash, and in the block, even though we say transaction is like similar to one transaction is sending money from one person to another one. Those are the transactions, right? If you do account those kind of transactions. So one block may have many transactions. Okay. So there are many transactions, and all the transactions are managed in the block using Merkle tree. Merkle tree is a hash tree, so its hash functions are used. But at the end, the blockchain has some of transaction in the form of the tree. So other than that, blockchain normally has a timestamp, so you can see when this transaction happened or this block was inserted, and the hash values. So the blockchains are linked through link is one way to link list linked through the prim hash. So the blockchain hash value will be put in the block 11. Block 11 hash value will be put in the block 12. So if you want to insert something in the middle, you need to change every node after the block 12, because you need to change this previous hash value. If you change this one, this hash value will change. Then you need to change each and every values in the block. So it's very hard, almost impossible to change or add something in the middle, or change it or edit it. Even though edit it, you need to change this hash value. So that's why this hash and this link mechanisms are used in the blockchain. Okay, the other concept is same thing called mining. So in the block, we have data, we have a hash, that is the previous block. But we want to create a hash, or the exhibited hash pattern should have some specific characteristic pattern, starting with 4 zeros, 5 zeros. If you have some random data, you can create a hash with using any hash functions. So now you understand nonce. Nonce is called a dummy value, which helps to make a specific pattern of hash for this data. So the mining operation is identifying this value. So you need to there's no mathematical operation, so you need to try and error. But that's why it's very complex, computation expensive, and so there are proof of work, proof of stake. There are some different mechanisms that they are. So the nodes which are doing the mining operation called miners. When you do the transaction, whoever do the first validation will get some rewards. That's why in the Bitcoin mining and getting Bitcoin, that's where it comes here. Bitcoin is part of blockchain. That's what the first blockchain, but blockchain has more general than Bitcoin is one application. So how blockchain works? So let's say Alice want to transfer to Ben. So he will send the transaction to every node, and those few nodes will try to validate the transaction. And then once it's validated, it will add it to the block and broadcast the block to everyone. Then everyone in the node will approve it through the consensus mechanisms, and then it will add it to the block list. Once it's added, you cannot tamper it or you cannot change anything. So after that, money will be sent to Ben. So this is how the blockchain works. It can be money or any kind of data you can work. So as I mentioned, the Bitcoin is the first blockchain introduced, but with the time, blockchain evolved. So one is programmable blockchain. So in the Bitcoin, we have a transaction. After Satya, we put this in the blockchain. But in the programmable blockchain, we have option to script language. So we can program it here. So we can put some logics, some conditions we need to make to transfer this money. So we can write script there. That's why it's normally called smart contracts. So similar to the contracts are maybe between two party or multiple parties, and they execute that. If any issues, you go to arbitrator and solve it. Similar to this one, smart contracts are enforced in real time on blockchain. So it has a ground rules. Terms and conditions need to be recorded in the code. You can write in the code, and you can say if these conditions are met, transfer this money or do this transaction. So and those smart contracts will be executed in the transaction validations in every node, and then those validated once whoever validated will send those values, and that will be verified within the nodes without any third party. So there are a few blockchains supporting these Ethereum, Hyperledger, Fabric, Matic. So Ethereum is the most popular one. So Ethereum uses Solidity, the programming language similar to JavaScript, to write this code. And when you write the code, when you transact it, whoever mines, we need to pay it. The cryptocurrency is Ether. And in the Ethereum, normally those are if you want to start blockchain, that's the best point to start using the Ethereum. There are applications you can build using Ethereum, those normally called as dApps. And once you build the dApps, you can try the HTML or JavaScript application that make interfaces. Even you don't need any servers. Even you can launch it in the SWAM or IPFS. Those are the distributed file systems, and you can, without any servers, you can have applications running there. And of course, Ether is expensive. It's not similar to Bitcoin, so you can't pay in real time if you want to test it. So for that, if you have a test simulators, Ganache is one of the simulators you can use. Similar to the main Ethereum blockchain, there are test public blockchains which you can use with the test ethers. So Ropsten is one of that one. So you can, if you want to, you can try Ropsten and you can try these applications. And once you're done, you can go to the Ethereum. Or Matic is less expensive compared to the Ethereum and has a similar functionality. You can try that as well. So other involves its blockchain is in direction of private blockchain. So the public blockchains are permissionless. Anyone can join it, mine it, or see or view. So there's no authority, or there's no authority to authorize to perform some such actions. Everyone has equal priority. So Bitcoin, Ethereum, Monero, Dash, or Litecoin, or Matic, anything, everything is here public blockchains. But problem with these public blockchains are slow, because normally 7 transactions per second, and it's very, you cannot scalability issues are there. You cannot go big because blockchains lengths are high, and it will take a lot of time to translate. And current concerns are energy, green energy kind of concerns are there. And so and also for those kind of purposes, the private blockchains were introduced. The private blockchain kept within the community, so nodes need to be permissioned. So there is one authorized node who can join the blockchain. So it's kind of less decentralized compared to the public, because you have some authority to one authorization node. So that's why trustworthiness is little low, but it's depend on application, because trustworthy depend on that authorized node. So Hyperledger Fabric, so a few of blockchain, private blockchain, mostly the IBM related works. So with using these kind two properties, there are hybrid or consortium blockchains which has property of public chain, private chain. So instead of having one authorized node shared or the authorized node, and so R3 is one of that one. So these are some involvement in blockchain. So it's depend on the application. If you want a more trustworthy, more transparency network, you need to go with public. But if you want to keep within the community, so you have only you want to use the blockchain for only authorized persons. We have called for private networks, private blockchain. So that's the overview of blockchain. So now, if you go to the opportunity, of course, in the finance domain, and the problem with the finance domain is you need a third party and time-consuming costs, and there are bureaucratic steps are there, and less transparency. And if you want, so to solve those issues, there are digital currencies are introducing, including Litecoin, Bitcoin. Those are the, so there are some applications you can how to manage those kind of things, transfer, exchanges, those kinds of applications are there. And also even the share market markets for them, and transferring ownerships, clearings are done in the blockchain. So you can easily clearing. Normally share market clearing take 2 to 3 days. Here you can instantly clear them because you can easily validate it without going for too much of the bureaucratic steps. And the other one is, let's say you go to the bank, even though you give the check, you can even change it, add additional zero, change it, or someone in the bank sometimes happens, change it. Or so there's a little trustworthiness is there. So the blockchain solves those kind of problems as well. So these are some opportunity in the finance field. So on the other main field is healthcare. So on the healthcare, main issues are less access to the information across stakeholder healthcare, involved with doctors, patients, pharmacies, insurances. We need to send information back. They need to access each information to come to decisions, research into institutions. So, so on the information, less access to those informations, and also time consuming. If you go even change the hospitals, it will take, you need to bring some written books. And also data integrity and security is another issue. And other issues where patients' data there's a private sensitive data. Patients may have concern whether this is sold to someone to earn money without their control, without notifying them. So those kind of issues are there. So the blockchain's ability to keep an incorruptible, decentralized, and transparent lack of patience give a solution for this problem. Because blockchain, you cannot corrupt it, you cannot edit, or you cannot change it. You can, everything is there, lock is there. It's decentralized, so easy to access. So it's safe and secure, and it's a decentralized nature. Give the quick access because it's decentralized, and also easy to transfer data within blockchain, and also smart contracts. Or sometimes it's a private blockchain use if the access is given to the specific hospitals and pharmacy, not for every patient. So, and in the case private blockchain, you can access it per blockchain. There are concept called channels, whether you can differentiate inside the blockchain as well. So those, and also patient control. There are two ways. Even smart contracts, patient can control it. Who can view it? So this is one example. So nowadays, the healthcare is evolving with the IoTs, AI, and blockchain. So IoTs are used to get the patient's medical parameters, census values, blood pressure, temperature values, and every values, and those are used to AAs are used to come to decision, medical decision or disease prediction. At the same time, the data issues are there. For the data issues, the blockchains are used, so it's secure and it's decentralized. And also, patient can't control the data. Let's say some healthcare provider, pharmacy, or research institution want some patient's data. They will request it and they will offer a reward for you. So patient can check it and they can agree to disclose their data, and everything is done in the smart contracts. And patient will get reward for that one. And research institution or pharmacies, anyone who want the data will get the data and they can improve their business. So this is one of the business models mostly popular these days. Now, there are like medical chain, those are some popular blockchains applications. And other application is Internet of Things. So normally Internet of Things have a lot of data and is connected to the cloud, but it has a problem, single point of failures, because everything database, so it's one point. If you access that one, you can change it or you can crack it. So, and the other one is the data integrity and confidence issues. Third one can access and change it, or they can stop the census value and they can replay attack. And there are cyber attacks, access it, encryption. Without encryption, if you store without encryption, you can access and view cyber attacks. So blockchain keep the solution for this one. There are a few blockchains support this one, but there are some issues with the current blockchain as well. Scalability issue, because IoT has billions of number of transactions, but it's small, but million. So every transaction, you need to pay the cost for mining and everything, and its computational requirements high. So scalability issues are there. But even though the Hyperledger, Iroga is one of application. Other popular application is IOTA. So if you want to do something in IoT blockchain, IOTA is one. IOTA replaces the block and blockchain with a Tangle. So because it doesn't have a block or chain, so it's normal blockchain, but it's used its ideas about, and it's mostly popular for IoT. So Tangle is no more a block. It's a transaction tangled together using the directed acyclic graph. And it's very scalable, no fees, so it's lightweight. So it's good for IoT applications. So other opportunity in logistic field. One problem in logistic field is lack of communication and transparency, because a lot of logistic companies are involved in the supply chain. Let's say you go to the shops A and you buy some product which should be kept in the temperature controlled environment, and you found some damages are there. And if you go there and claim it, they will say they kept everything good, but it's problem with their supply chain. If it's supply chain, they will point it out. No, they did everything fine. They will point it out the manufacturer, the factory. So the problem is how to find this truth, or how to find the truth. One application is IoT, of course. You can have sensors and you can track those temperatures, like from production to the delivery. But even though it's IoT, each company has its own access to database. You can still change it. So even though it's issue with the supply, one supply may change it. Some issues saying that this was the data they received from the manufacturer, and they can change it. So there's integrate. So those kind of issues are there. So how to handle it? The blockchain is the best solution, because you cannot tamper it, or you cannot change it, or you cannot, timestamps are there, and it's encrypted, and you can control it. Who can view it through the smart contracts? And so this is one kind of application for the logistic field. So other field is like you can, in the blockchain, you can have the progress of the delivery. So from the manufacturer to the shipment to the delivery house information, everything you can manage, and you can even pay through the cryptocurrency. So other one is document controlling. You can through the smart contract. So this is the typical logistic, the first top one. So normally there are a lot of documents involved, and you need to check it, you need to transfer them, and you need to check, and it's time consuming, and then you transfer, ship it, and it's delivered to there. So if you apply the blockchain, here the private blockchain might be a good example in case you don't have too much information, too much nodes. Otherwise, you can use the public blockchain with the strict control on the smart contracts. So you can put every document, everything is a blockchain, so it's easily accessible, and you can control who can view, how to send it, every logics in the smart contracts until you receive it, and everything is back and forth. So once you receive, every smart contract is here, and the manual works are not automated in the blockchain, and also secure transparency, every issue is solved. So these properties give a lot of application in the logistic field. So other popular application is NFT. It's a second most, recently it's more popular next to Bitcoin. So NFT is a non-fungible tokens. So NFT is a unit of data store on the digital ledger blockchain that certified a digital asset to be unique and not interchangeable. So normally NFT are used in the digital items such as music, arts, videos, and they can be sold in the blockchain while keeping the claim of full ownership royalty to the creator. So to keep the royalty to the creator, you can still have the contracts, and you can control how much space should be done to the royalty, and you can still buy and sell and transfer these ownerships. So these are some characteristics of NFT. So it's non-interruptible and indivisible and easily verifiable, and one official owner at a time. And normally it's secured by blockchain, so it's a part of blockchain. So no one can modify its record or copy or create a new same thing. And smart contracts, and you can use smart contracts to keep the royalty or some logics there as well. So nowadays it's becoming more popular, from media to even they are thinking about discussing, or there are some applications going on how to sell the clothes or physical things. Of course, there are some limitations, something you need to consider, but it's still going on. So these are the most popular NFT applications. So if you're interested, you can still see what are the opportunities here, and you can come up with a good business case. So other sectors is decentralized identification card. Currently, we have identity card given by government, and it's a documentation. There are a lot of cards from birth certificate to NIC. If we lost it, it's time consuming to get it. And also you can easily damage it or forge it or forward it. You can change it, or even you can. So those kind of issues are there. So those to tackle these issues, blockchain, you can put them in the blockchain, and it's decentralized. So everyone can easily access it, and it's secured. And also you can use across the countries. If you come to some other countries, you need to spend a lot of time to prove your address or kind of issues, or because they want to identify users, or they will request some bureaucratic steps out there. You need to keep this document, that document. So this blockchain solves those kind of problems. So in the smart contracts, you can easily control who can view your data, and even it can be notified if someone else try to access your private data. So these are the other sector is land registry or deed transactions. Let's say you want to buy some piece of land, and you checked it land registry, and then at the time you find and you bought it. Someone may come and claim this is their land. This happens, especially in countries like Sri Lanka. So problem might be some fraud in the land registry, or someone did some fraud, but you don't know who did it. There's no way to avoid it. So for these kind of things, because blockchain's ability to keep every history, and it cannot immutable or cannot change, those kind of properties give the good opportunity to give application on these kind of applications. So other one is the media. So with the interaction of media, with the popularity of NFT, the media, the issues, the royalty payments are tackled. And the other issues are data privacy, piracy of intellectual property, those kind of issues also tackled. So other than that, other applications are like voting system, online vote. They also, because the votings are expensive, arrangement for the voting systems are expensive. So one other application is voting systems. Insurances, you can have a peer-to-peer insurance without an insurance company. So what? Yeah, you can, if you, even though you have idea for your startup, you want to work with else, you can still project your idea. There are smart contracts, and you can work collaborate it. So you can track it. So who had the original idea? Those kind of issues. So those are some opportunities. So blockchain is constantly evolving, and it's creating a lot of use cases. And so there, because it's property of trust, transparency, accountability, decentralized nature, since it's giving sense of democracy because equal, everyone has equal priority, and smart contracts giving a lot of business opportunities. So those kind of things creating a lot of opportunities. So you can think of some issues related to these and come up with some idea and see whether you can apply blockchain. Of course, there are some concerns there. You need to be careful, or there are some, still blockchain is evolving and a lot of researches are going on. One issue is scalability. You cannot have higher volume of transaction if you want more than 10, because currently 7 to 10 transactions per second. If you want more, of course, there are lightning blockchains, private blockchains, you need to consider them still. Other one is lack of industry standard. So everyone uses different blockchains for application, but to be the blockchain success, everything should be integrated better. So cross-community issues are there, some researches are going on there as well. Other issues related to the regulatory and compliance challenges. One is right to forget, because one of the privacy act is clients should be given option to delete their details. But if you put every data on the blockchain, you cannot delete it. But there are some options like don't put the sensitive privacy data on the blockchain, keep something else, and keep the hash value there. Those kind of approaches there. Other one is called off-chain. So off-chain is you keep the data out and keep the hashes in the blockchain. Other issues are related to the implementation and integrations, because blockchain was evolving, you need to change it, you need to be updated to keep long time, because it's new field or it's emerging field. Other one is the data size, because this transaction size, if you have a lot of size, you need to pay a lot of hash, or you need to pay a lot of either some cryptocurrency to mine it and add it. So those are, if it's size, you need to pay a lot. Those are not suitable. So for that purpose, they have off-chain concept. So you keep something and keep the hash, so cash cannot be changed. So everything is keep in track there. So it's hybrid thing. Other main challenge is everything is cryptocurrency, and its private key is lost or stolen. There's no because everything is accessing private key. Normally you keep in the wallet, but if you lost that one, there are some issues there. So these are some concerns. So of course, research and there may be, so you can come up with some ideas, so you can merge some other ideas and solve these kind of things. So these are things you need to consider, and there are a lot of opportunities out there. So you can come up with some idea and you can be a good success entrepreneur in that field. Thank you. If you have any questions, you can ask now.
Thank you, Mukundan, for that interesting presentation. So if anyone has any question, you can post it on the Q&A section, or else you can also raise your hand so that we can unmute for you to answer, ask the questions. Mukundan, there's a question on the Q&A.
Yeah, so of course, in the public blockchain says it's anonymous, you cannot track it. But it's a unique ID, so you can track using the same transaction. So unique ID is there. So based on that one, you can track, like if you have a lot of transactions, if you know about transactions in somehow or some originated kind of things, those kind of approaches are they use. If it's a private blockchain, yes, but I don't have exact idea how they found it. It's recently I saw this news, but of course with that your activity, you can track the activity with the same address, and you can, that might give you some options to track who did it. But I don't exact answer how did it. I need to also check it.
Yeah, so for the benefit of the listeners, let me read out the question. So there was a question. In general, we can't track blockchain transaction to personal identifiers. It's anonymous. It's built into Bitcoin's fundamental values. So the viewer have read that the US has recovered some millions paid in ransom to Colonial Pipeline hackers, and how is it possible? Yeah. So thank you for answering that question, Muhunder. Any other questions? Yeah, so Muhunder, looks like there are no more questions. So that I think we are good to